Welcome to the course of differential equation. In this session, we will discuss about the method of undetermined coefficients part 5. We already discussed the fourth session related to method of undetermined coefficients. There we discussed it is that a non-homogeneous linear differential equation of the form a y double dash plus b y dash plus c y is equal to r of x has general solution as y is equal to y h plus y p, where y h is the general solution of the homogeneous part a y double dash plus b y dash plus c y is equal to 0, and where y p is a particular solution, that is y p is a particular solution that we need to determine by using the choice of the r of x, the non-homogeneous part that we discussed before. It is that there we discussed it is that there are some choices for y p. If r of x is exponential function, maybe r of x is polynomial function, maybe r of x will be trigonometric function, maybe r of x is their combination. So, on that all cases we will have a general choice for y p that we defined, and after applying that y p in the original differential equation that we need to solve, we will get the values for these coefficients or constant values. Then we will get a particular solution for a special particular solution for that non-homogeneous equation by using the method of undetermined coefficients. Okay. See, in this part 5 we will discuss it is that the rule function, that is the modification rule. We already discussed it is that in rule 1b, that is if maybe r of x is sum of two functions from the column 1 of the previous problem that we discussed, then we will write y p as the corresponding sum of the choice of y p, and then we can find y p dash, y p double dash, then we will apply into the equation, we will get the solution for particular solution for that non-homogeneous equation. See here in this modification rule, it says that the non-homogeneous part r of x is one of the function from the column 1 that we discussed in column 1. Okay. And also that a corresponding homogeneous equation has many choices y p that we discussed in column 2. Okay. See, on that column 2 we will have maybe if the characteristic equation, we can have the homogeneous equation, have the characteristic equation. See, here we will have this homogeneous part, we will have here, then we are able to write a corresponding auxiliary equation as or characteristic equation or auxiliary equation as a m square plus b m plus c plus b m plus c b m plus c equal to 0. See, this is a quadratic equation. We can find the roots for this quadratic equation. There we discussed it is there. They have three choices for the roots for this quadratic equation. That roots are maybe real and distinct, or maybe complex conjugates, or maybe sometimes maybe that may have the double root, that is the only one root will exist, that is the repeated root. Okay. So, in this case if the characteristic equation of a homogeneous part has a simple root, then for y p we will choose the column 2 that we discussed when we started the method of undetermined coefficients, and in section 4 also we discussed it is there. There will be the choice for y p is there, we multiply that by x, then we will get a choice of y p. That what I mean it is that dear student, just listen to here, it is that we discussed here. See, if already some may be there may be some e raised to p x is there in the solution of the homogeneous part, then see dear students, we just multiply, instead of c e raised to p x we just multiply c into x into e raised to p x. Maybe sometimes this is this p and x is the solution, maybe rare chance is there. In exponential case, maybe in trigonometric case is there. Suppose if there is in homogeneous part there is cos px or sin px is there, then we just multiply that term with an x. So, we redefine yp like that. Maybe if suppose the auxiliary equation or the characteristic equation has double root. See dear students, what will happen it is that we just multiply, there is the as because if that is double root, we know that it is if they are double root. So, we will have this is equal to sometimes the general solution that yh can be written as, say this is equal to c1 plus c2 x e raised to px is there. So, in general solution we will have the e raised to px. In general solution we will have, see in general solution we will have this e raised to px is also a solution, and also x e raised to px is also a solution. If suppose r of x is there, in r of x an e raised to px is there. So, already we have the solutions as the e raised to px is there, x e raised to px is there, that will form a basis, they are the independent solutions. So, to find while finding yp, we are unable to consider that as either e raised to px or x e raised to px. On that case, we just multiply the term in this one choice of yp, we will multiply with the next power of x, that is the x square, that is the cx square e raised to px is there. So, or otherwise sometimes here maybe rare chance for that. So, if there exists a choice, that also we will consider on that case also, but actually that have very rarely we can consider that. So, on that case we just multiply with the x square. To understood this, we can demonstrate with an example. Next example, solve the initial value problem. Solve the initial value problem. See the initial value problem says as to is that y double dash minus y dash, y double dash minus y dash minus 2y is equal to minus 2y is equal to 3 e raised to 2t, 3 e raised to 2t. This is the first question, and this that is why with the initial condition, because that is initial value problem, there will be an initial condition is there, y of 0 equal to 0 and y dash of 0 equal to minus 2, y of 0 equal to 0 and y dash of 0 equal to minus 2. This is our question that we need to solve. While seeing the question, we understood that is an non-homogeneous linear differential equation with the constant coefficients. Okay, definitely we can find it's the solution of the homogeneous part. So, as part of solution, we can write the auxiliary the homogeneous part as y double dash minus y dash minus 2y equal to 0, minus 2y is equal to 0. So, dear students, we will have the auxiliary equation or the characteristic equation as m square minus m minus 2 is equal to 0. See, dear students, we will have this one 1 into minus 2 into 1 is equal to minus 2 and minus 2 plus 1 is equal to minus 1. Okay. So, we can write this as m minus 2 into m plus 1 equal to 0. Fine. Therefore, we can say that the general solution that is equal to m1 is equal to m1 is equal to 2 and m2 is equal to minus 1. Okay. Fine, m1 is equal to 2 and m2 is equal to minus 1. So, dear students, we will have the general solution. Therefore, YH, the general solution of the homogeneous, what YH is equal to, the roots are real and distinct. Therefore, we will have the general solution C1 e raised to m1x plus C2 e raised to m2 of x. Okay. That is equal to that is YH is equal to, we will have C1 e raised to m1 of x, that is equal to 2x plus C2 e raised to minus x is there. See, dear students, here this is the general solution of the homogeneous part. So, in the homogeneous part, we will have e raised to 2x is there and C2 e raised to minus x is there. See, compacto question, see here we will have this is equal to 3 e raised to 2t. Instead of t, I would like to consider that as, instead of t, I would like to consider this as x. Okay. C1 e raised to 2x is there. Okay, fine. We have 3 e raised to 2x. So, e raised to 2x is already we discussed here. Therefore, for choice of yp, we already discussed here r of x is equal to 3 e raised to 2x. See, r of x equal to 3 e raised to 2x is there. So, for the choice of yp, 3 raised to 2x is here. Already e raised to 2x we have, here we have and e raised to 2x, and in r of x is also e raised to 2x. So, by the modification rule, we have to multiply for yp, we have to multiply it with an x. Okay. So, therefore, yp is equal to, therefore, yp is equal to, this is equal to this one c x e raised to 2x is there. Now, no problem, because the roots of the characteristic equation is simple root. Fine. Okay. So, we can find the yp dash. So, yp dash is actually this is the first one and this second one. I would like to consider this as the c is the second one, that is x into e raised to 2x into 2 e raised to 2x. Okay. And plus this is the again we can multiply e raised to the second function e raised to 2x into derivative of x is 1. Okay. Derivative of x is equal to 1. Okay, fine. So, yp dash is there, and the next one is yp double dash. Yp double dash is equal to, actually yp double dash is equal to c into 2x is there. So, we have this is equal to c into x into c is there in outside. We will have here this is the first function and this is the I would like to say the 2x is the first function, e raised to 2x is the second function. Okay. Therefore, we can have this is the 2x into derivative of e raised to 2x, that is equal to 2x into derivative of e raised to 2x, that is 2 e raised to 2x is there, plus again we will have e raised to 2x into derivative of 2x is 2 plus derivative of e raised to 2x is there, derivative of e raised to 2x is 2 e raised to 2x, 2 e raised to 2x. Okay. So, therefore, we can say that this is the yp double dash is equal to c into 4 x e raised to 2x plus we have 2 e raised to 2x is here and again 2 e raised to 2x is there, 4 e raised to 2x, 4 e raised to 2x. Okay. We just apply in 1. Okay. While applying to 1, we will have a plane, say a plane, our differential equation is y double dash minus y dash minus 2y is equal to 3 e raised to 2x. Y dash minus 2y is equal to 3 e raised to 2x. y double dash minus y dash minus 2y is equal to 3 e raised to 2x. 3 e raised to 2x is there. See, dear students, we will have instead of y double dash, I would like to consider this is the y double dash is actually yp double dash and yp dash 2yp minus 2yp. See, yp double dash, here we have yp double dash is equal to for c x e raised to 2x plus 4c e raised to 2x, okay, and also we will have again minus yp dash is there, minus of this is the yp dash is actually yp dash is equal to 2x 2c x e raised to 2x minus 2c x e raised to minus 2c x e raised to 2x, okay, minus 2c x e raised to 2x and minus c e raised to 2x minus c e raised to 2x. So, yp dash minus 2c x e raised to 2x and minus c e raised to 2x minus c e raised to 2x. Fine, and this is equal to yp dash is there, and also we will have the yp dash is there, and finally we will have the value see here minus 2 yp is there. So, actually yp is actually we have yp is equal to c x e raised to 2x is there. So, this is equal to finally minus 2 yp, 2 yp that is equal to c x e raised to 2x, that is 2 c x e raised to 2x, okay, fine. This is equal to minus 2 c x e raised to 2x is equal to 3 e raised to 2x. 2 c x e raised to 2x is equal to 3 e raised to 2x. Okay, see yp double dash is equal to 4 c x e raised to 2x and plus 4 c e raised to 2x and minus 2 c minus yp dash is equal to minus 2 c x e raised to 2x and minus c e raised to 2x minus c e raised to 2x minus c e raised to 2x is there, and finally yp is equal to minus c e raised to 2x is there, and finally we have minus 2 yp. Yp is actually here c x e raised to 2x is there, okay, that is equal to yp is equal to c x e raised to 2x minus 2 c x e raised to 2x, and we have the RHS is there, that is equal to 3 e raised to 2x. Okay, so RHS is 3 e raised to 2x is there. So, dear students, we can consider this as here see consider this is equal to here we have the term 4 c x e raised to 2x, consider the terms, we will have 4 c x e raised to 2x and minus 2 c x e raised to 2x minus 2 c x e raised to 2x. So, plus 4 c x e raised to 2x minus 2 c x e raised to 2x minus 2 c x e raised to minus 4 c x e raised to 2x. So, 4 c x e raised to 2x minus 4 c x e raised to 2x is, that will be cancelled. Okay, this will cancel, and finally we have 4 c e raised to 2x minus c e raised to 2x. Okay, 4 c e raised to 2x minus c e raised to 2x. So, we will have 3 c e raised to 2x is there. So, we will have 3 c, therefore, we will have 3 c e raised to 2x. See, dear students, we will have the 3 c e raised to 2x is equal to 3 e raised to 2x, okay, is equal to 3 e raised to 2x, 3 e raised to 2x. Okay. So, we have this is equal to, from here we will have 3 c equal to 3, therefore, c is equal to 3 by 3 is equal to 1. Okay. Fine, dear students, we found the value of c, actually we took yp as c x e raised to 2x. Therefore, yp is equal to, so we found, therefore, yp is equal to, so the value of c is equal to 1, therefore, x e raised to 2x, x e raised to 2x. Okay. So, yh is c1 e raised to 2x plus c2 e raised to minus x is there. So, dear students, here we will have this c is equal to 1, therefore, yp is equal to c e raised c x e raised to, that is equal to x e raised to 2x is the yp. Therefore, the general solution, therefore, general solution of given non-homogeneous differential equation is actually that is the y is equal to, the general solution is yh plus yp. This is a complementary solution, yh is there, that is the solution of the general solution of the homogeneous part. Therefore, y is equal to, yh is equal to c1 e raised to 2x plus c2 e raised to minus x plus yp is equal to x e raised to 2x. See, we got 3 independent functions. Now, this is the general solution of the given, non-homogeneous differential equation. Okay, fine. So, this is the general solution of the given non-homogeneous equation. See, dear students, what we did actually it is that we just multiplied. This one here we have c, while evaluating this one yp, see here we have the independent functions as e raised to minus x and e raised to 2x, and r of x is equal to 3 e raised to 2x. So, since the auxiliary equation has the symbol solutions, therefore, we just multiply with x. Suppose if the auxiliary equation has double root, then we will multiply, instead of x is equal, we just multiply x square. If that is double root, then only we will multiply with this one x square. So, on that case, this is yp is equal to c x square e raised to 2x maybe will be there, and we will find out yp dash and yp double dash. Then we just apply to the given non-homogeneous differential equation. Definitely, we will get the value of that c. So, we will get the particular solution for that corresponding differential equation. There you can find many questions in our literature. I would like to say give you one more question, it is that so find particular solution. I would like to give you an assignment question as solve non-homogeneous equation, solve non-homogeneous linear differential equation y double dash plus y double dash plus y is equal to sin t, okay, is equal to sin t by method of undetermined coefficient, method of by method of undetermined coefficients, by method of undetermined coefficients. So, my dear students, there you can find many questions from the literature of the differential equation. I left you for your freedom to find many questions related to this non-homogeneous differential equation that you can solve by using the concept of the method of undetermined coefficients. That is a very nice portion of the differential equation. Thank you for watching this video. Continue your watching. Thank you very much.